Hello folks, it's Monday, I think it's about the 8th. So, we're kind of moving on to a customer set, but we're not. It's Mark ZX2s, and it'll only get one session at it. And the video will go out whether it's fixed or not, just in case it's interesting. So finish box 44, this is box 45. It's a Kernow Beta 5100. I think we've got one of these somewhere. I've got no info on it. And it has a cell call socket on the back with no jumper. Now normally you have a jumper for cell call sockets. So we've bought in a jumper in case that's why there's no audio on receive, which is the reported fault. This is pretty rubbish, but there's 3 videos which you haven't seen anything of, which we didn't get anywhere with. The Falcon Alan kindly sent in so far has had 2 sessions on it. Problem with the phase lock loop. The Fidelity 2001 I bought off eBay 6 months ago has had mains up it. I've got PA back working after changing a lot of parts, and or something else as well which we did. Right, so this is Mark's. So we do know it does something. Now, it's a 4-pin mic, so we could assume that it's going to be Cybernet type of wiring. So we'll get the Cybernet mic. In case I'm right. On. Yep. It says on. So it's PR2797, so it is an 80 channel UK FM set and EU as well. So with the signal generator on, so what I'm going to do, we'll see whether it's actually receiving blind, if you get me what I'm saying. So let's put the frequency display up. So 2779125. Right, and need to unplug the test lead from the other test set on the bench behind, which I'm using its deviation meter. I've bought a supplementary deviation meter. I know we do have a Ray Cordana one here, which is currently on the bench as a third option, because as I say, we've got snags with the deviation meter on this test set, and if I took this test set off this bench, it would mean doing a lot of tidying up, and that would mean we couldn't do any jobs, because it couldn't be just done in one day. So it's got to stay, and then we've got to fix it, haven't we? So we've, like with the Synod meter, which doesn't work on the test set, we'll just put an extra thing. So I've ordered a Heathkit one from the United States, obviously broken. We'll do a video on fixing that and aligning it. Everything with Heathkit is going to be repairable, and that's the attraction to me. So we've got channel 20 on there, we've got the signal generator in, and well, I've got nothing coming up on receive. So is it transmitting? And the answer is yes, it is. So let's go. Oh, we can see the frequency for a start. Oh, it's on EU channels. No wonder it's not receiving anything. And it does say EU. So just press that button, go to UK. Annoyingly, it's gone to channel 1. It is receiving. Turn the signal generator down. Press transmit. 2779106, slightly off frequency, and we'll go over to the power meter and we'll see what it's doing. It's just doing a little bit over 3 watts, 3.1. So that's good. Have we got deviation? Wallow. And you know what? I think our meter's working at the moment. Good. So, is it just that we need to have a cell call jumper plug-in. So somebody's selling these on eBay. I think they're $5.99 delivered. So I ordered one just in case. So if it's done, shall we say, the standard way, we still have no receive. Unless, of course, the speaker's faulty. So we'll plug in the extension speaker. You have an external S-meter socket. We've covered that before. No, there's no audio. I better take the screws out of it. So to me, all that can be wrong is the audio IC. It can't be anything stupidly complex if it needs that jumper plug. But I can't find anything online on this model. I'm sure we've got one somewhere. We're supposed to have one of every set, but I don't think it's one that we've pulled out of storage to do a video on yet. Well, there wasn't going to be any audio, was there, because it wasn't connected. Just to double check, because most sets with cell core, you've got to have a switch on the front to say what's what. I can only put 40 minutes into this. I've got a lot of technical queries by email, and I've had to say to everybody over this coronation weekend, I've had so many services to play the organ for that anything CB wise has just gone by the by, as you can well imagine. So where is our audio? Well, so there would be a modulation transformer there in an AM version of this. We've got a supplementary board here for whatever reason. We've got a supplementary board there, which is probably I mean, this isn't a conversion, but it's probably had factory jiggling to do UK. There's a couple of presets on that. No, there's just nothing on there to kind of help. Right, without looking this up, just see what the power input is for the audio IC. The 14 volts on there. 12 on there. So I'll just see whether we've got, without looking, if I looked up the chip I could. Right, so that's our FM noise. It's gone back to, why does this keep going back? Oh, because I shorted the power out, that's why. Looks like it defaults to EU every time, and channel 1. How annoying. So we can hear, we actually do have audio. So if I look at the speaker socket, what we haven't got is audio there. So I'll just pull out this jumper. I'll just put the meter on the cell core socket, make sure we don't touch 12 volts. So that pin is power. And that pin, so we don't want to touch that. It's crocodile clip lead time, and it's not Mr. Chippy's, it's Alan's. No, we've not got any audio to there. So we've still got audio to the audio IC. Yep. I think we've got to change the audio chip on this as a precautionary thing. Right, so I'll get one of those out there. It's TDA2002, we've got those in stock. Right, so we've got somewhere with it. So I've, for a start, did a bit of research and found out it's a Stabo 4082 in Germany. Without looking too closely, I don't know whether that's AM, FM or whether that's AM only. Anyway, frequencies aside, we've got the same kind of thing, and it looks to me like the cell core doesn't need any kind of link. It doesn't come in at audio level. So when I actually look at the audio IC used, I'm telling you all this, and where is it? Yes, it says TDA2003. Well, I've just taken it out to TDA2002. So now we've got audio. I hate the way this keeps resetting to channel 1. Bit noisy volume control. So we need to go through this and do a tune-up. I don't know whether this board's used in anything else. Now this doesn't have to be perfect to go back to Mark, because at the end of the day he's a radio engineer, but he was just struggling with that, and I'm not surprised. It's a matter of cross-researching and or seeing another one and with the wrong audio IC in. This is the problem. Something about the 20, probably the 28. No, it's the 8th probably. So it's box 45, set 1 of 1. So I'm expecting the transmit lineup to be down there. I don't even know that I'm going to optimise it on UK channels. And let's see where we were with the power. Picture in picture on. It's now 3.2 watts. I think it's supposed to be backlit, but it isn't. So UK 1 is 3.1 watts. UK 40 is 3.1 watts. Doesn't have low power because it's not a 2781 set. And if we go back to channel 20, it's drawing 1.126. Deviation, wallow. Well, I can't tell with this test set, can I? Wallow. 1, 2, wallow. 1, 2. No, I can't tell. We'll come back to that. We're not going to do the VCO. Wouldn't know how. I'd have to do a lot of research to work out how. Frequency is. Let's look at the. I've still not started in answering any technical questions which people have asked. It's 2779113. And the receive. Let's go over to the synod meter. To be honest, it's probably not much else wrong with it. For 12 dB, we've got 0.5, that's jolly good. For 10 dB, we've got 0.32. Can't be 0.5, I've misread that. Well, it is. Better than I thought. And for 20, it does that. No. Squelch on full. Is 1 millivolt. And on threshold, is 0. No, it's not. It's 2.1. Which is a bit strong. TX meter says, well, it says it's 0 to 9. It's like a, and on receive for 100 microvolts it's saying 7, so to get 9 it is 100, 300, 225 microvolts. No, yes, no, I don't know about that. So, see whether we can do the transmit. Let's peak. That's peak. So no change. Looks like they're about 1997. Where's my... Oh, that's 3.3. Is that meter, or is it some kind of power preset? It is power, so that will bring it up a little bit. Recheck this. It's doing 3.5. Just check these haven't been messed with. Yes, that's not quite right. .6. Right, if I can see the tiny print on a photocopy of a photocopy. For something or other is S meter. So we'll put 469 is meter. Sorry, 469 is power. That would be AM if fitted. That looks to be in the receive section. We've got this subboard here. Looks like some speech processing thing. VR7 is meter. That's there. It actually says on my circuit. Now it's bounced the power, and now it goes back to EU channel 1. How frustrating. So it's not just new sets that are frustrating. Well, that's what it says. It's doing absolutely nothing. Right, I'm going to come back to some of this. We haven't forgotten that there's things to do on transmit. I'll bring it on frequency while we're at it. Go to the frequency counter. Seven nine 125. Don't say we've got different adjustments for different bands, because that's done nothing either. Let's go to EU. No, absolutely nothing. Right, as we were doing, I want to check the detector. So S9 equivalent, enough volume for a meaningful display. And let's see if we can spot where the detector is. L7, I would think. I think it's that, whatever it says. Yes. Just going to run through some of these IF ones, turn the squelch down. It just doesn't sound right. Now we'll do the front end ones. All spot on those. Gained a bit there. It's a plastic coil, so I've got to be very careful with the soldering iron. It's all very spot on, to be honest. So we'll have another look at where we are. I'm not showing you the synod meter. So we'll now go back to 12 dB, and we've got 0.32. For 10 dB, we've got 0.23. Just make sure I'm on the right mode. I am. And have we got 20 now? No. So it generates too much noise to do that. Right. See if we can adjust the squelch. Squelch to full. I would think it's the adjustment there. It's hard to tell from the circuit because it's, as I say, looks like VR5, and that looks like VR5. No, it's not that. So is it VR6 because that can also look like 5 on a copy of a copy? Yeah. That's it, 100 microvolts. So I'm just going to make a real rough note of this. So we've got TX power R469, we've got squelch VR5. We've got VR7, which is supposed to be meter. That's VR11. And then we've got one down here. Which also looks like VR5. I think that's 6. And that's VR5. There's 2 more on this subboard. So let's see if we can find the S meter. Let's go back to the attenuator. I don't need picture on. So 100 microvolts. So was it the one I twiddled, which is in the receive? Yeah, it is. There we go, S9. So that's that done. So deviation, well, that's never going to be deviation, surely. Let's get my oscillator on. Let's put that back on the screen and switch picture in picture on. I don't like to fiddle with these because I don't know what they are. Water. 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 citing as deviation. I just don't know what that is doing. So we haven't got it on frequency. We haven't found the TX meter. So this cares for a bit. This goes for a bit more study. So we'll come back to it. So if any of you can be bothered to look up this chip, it's a Mitsubishi M. It is 5228. It looks like Mitsubishi M5228P. And I think this is what's being used as a speech processor, because what would be down here, with it being an AM/FM set, the speech processing would have been done through there. So I took that out. We've adjusted that for the correct deviation. Definitely VR7 is power adjust, but it's not having any effect. I think the power we've got is beyond its adjustment point. And the other one, VR11, second one there, we found that was S meter. VR11 is external S meter, so you can calibrate your external S meter with that. So we've done that. We just haven't got the thing to adjust on frequency yet. I'm going to whip the front off. I'm going to try to, and I'm just going to see if we can get to the bottom of the meter lamps, or the display lamps, and the clean the controls. Right, so I've taken the front off the set. There's only one wire which is soldered, the rest of it is on connectors. And we find there's trimmer capacitors actually on here. So this is going to be where the frequency is done. So why have we got two? So we've got 4.5 megs on here, we've got 10.24 on there. So somehow we've got to set the 10.24. Otherwise, I've got a sneaking suspicion we're going to have the receive off frequency. I wonder if one's going to be transmit and one's going to be receive, which is frustrating for people who don't have two signal generators. I've really got to get to this because it's unusable with the way the volume and squelch controls are. It's quite a big hefty set for not a lot doing. You don't have to take the knobs off, because I think it's got one of these glow in the dark things in it. So what holds this in? Oh, it goes. So it's a rotary shaft encoder rather than a real channel switch. I've got two very small glorified presets which are used as the volume and squelch. There is a little gap, so I will be able to get the spout in. So does it have lamps or does it have LEDs? I think it's got green lamps in it, to be honest. Well, that's going to be fun, isn't it? I think we're going to have to take this down a stage further. I'm going to have to check them all for continuity, because the fact they're all out, they're either because it's in series or because they've all failed. But I'm sure I saw a point at which it flashed the lights, which tells me, wonder if there's a dry joint. So how's this next? Oh, there's a rusty screw there. It's got that end away. Ah, there's one. There's one there. How on earth did he get to that? Perhaps it doesn't go under the display. So the cracked bit of plastic inside was from there. You know what, I think you've got to take these two knobs off. I'm right. And the channel. There we go. Wow. Then you can get to that screw. So the front's a fiberglass board, whereas the rest of it is... Oh no, the rest of it's fiber... No, it's not, it's SRBP. Right, we'll just thread the cables through. And we now need to check each of these lamps for continuity. I wonder if there's a clue on the circuit, because there are differences on this synthesizer. I think it's on a different diagram. Yeah, it's a CPU. We've got that, I have to print it off. Right. Check for continuity. Open circuit. I'm on hold, aren't I? Try again. No difference. No difference. No difference. So all the lamps are open circuit. How wonderful. So you can see the little lamps with green covers. We've actually got green lamps. There we go, 4 lamps out. Right, I'll go and get the service on those controls, and I'll see if I can find the green lamps. Okay, so sometime later Mr. Chippy has changed all 4 lamps on this. We had the green ones in stock. The paperwork for this does show this board, it's here, and it's quite a faff to set it up, so we'll go through that. So, what have we got? When I can see the diagram, I looked at it on the computer before printing it out. So VR402, which is that one, we set for 2 kHz deviation. VR401, which is that one, we set for 500 millivolts peak to peak at test point 1. So test point 1 is at the junction of resistor 407 and capacitor 414. But you know what, I haven't got time to do that. Unless the audio is wrong on this, that's going to get skipped. I have to start working this out. And the other one, (403), adjust for best waveform. So that's best waveform, that's deviation. Good. So we'll look at that. I know the deviation meter's on up the spout on this, but at least we can see with the best waveform, hopefully. 1, 2, we can't see anything. I'm going to have to take this subboard out. To get to it. So there's 2 trimmers. I don't know why there's 2 trimmers, there's only one shown on the circuit. Perhaps one's coarse and one's fine. So we'll put the display onto the frequency counter and see whether we can get something. It's not that far off. I mean, it doesn't really need adjusting, but I'll just see. So that's moved it a bit. I'll just try the other trimmer and see whether it does the same. As I say, it might be coarse and it might be fine. Yes, it is. There we are, 2779126. That'll do me. Right. That warmed up the radio, I can assure you. But I've still got to set this. I'm just going to put this board back before it shorts out. Right, so where are we with the... yes, this. So we need to set 10.24 on here. And it does say TP just there, test point. So this'll, if I didn't do this, it's going to throw the receive out, I'm sure. So we'll put the oscilloscope on. So you really I'm just using this as a frequency counter. There's certainly nothing clever about it. Well, these are a bundle of laughs, aren't they, these sets? Switch it back on. It doesn't matter what channel it's on. The correct frequency on the signal generator, which we've got, 27.79125. The radio switched on. And now set to UK, got to go through the channels again. Channel 20. And 10.695, does it affect that? Take this tone off. No, it doesn't. So let's just see if it's the 455 it's going to affect. So it's recall. F2. No, it's not affecting the receive, so we do need to get 10.24 out of this somehow. Right, that was that idea quashed. So it doesn't. And let's see whether we can alter the shape with this trimmer. Yes, we can. That, I tell you what, we've got to, if we can, if you remember, we couldn't get 20 dB on the synod meter. Let's take this oscilloscope off. So I can't get an accurate frequency counter reading. Just unsolder that earth. This is what you've got to do when you educated guess. So I knew it needed to be set, and as it looks at the moment, it looks spot on. So it doesn't affect the frequency of either transmitter or receiver. It does affect the IF. So it wasn't the frequency of the IF, it's the kind of shape of the IF. Well, it is the frequency, but it wasn't showing up on the woo-woo box, the second signal generator. So I'm going to just see where we are with the 20 dB, because we couldn't get that before, if you remember. And now we've got 20 dB. So I'm just going to put this on the meter, on the screen instead. Let's put picture in picture. Oh, it is on, yeah. Put the bench light back on. Now, look, we've got 20 dB now. So I'm going to undo this. And let's just drop the signal a bit, see whether we can show that. No, it needs to be a whacking great big signal. So between the cyanide meter and the oscilloscope, I've got a good idea that we've cracked it. So we had 0.32 microvolts for 12 dB cyanide. We actually now have 0.26 microvolts. And for 10 dB, .21 microvolts, and now it will achieve 20. And I'll tell you what, it's not far off 1. It's 1.05. There you go. Well, that was a bit of a marathon. Right, we'll just pop down to channel 1. Turn the volume down. Just check the power. 3.5 watts. Channel 40. 3.55 watts. We've got that quite well balanced. Out of interest, we'll go to channel EU channel 1. It's doing 2.8 watts. And on channel 40, it's doing 3.4 watts. So down at the bottom end, I've put the power where it's going to be used, which is on the UK set of channels. And again, if the customer wanted over the 80, well, it would probably be back to 3.2 over the 80 channels. But this is for Mark, and we just can't use CPT channels because it's full of foreign interference. So go back to UK. Put it on channel 20 once again, and look at the ammeter. It's 1.6 amps. That's now on frequency. Deviation. Wallow. Oh, it's not. No. Wallow. This meter's playing up, so I'm going to have to do it on the one behind me. So let's be clear on this. without a lot of faff we can't do that voltage set. I'm assuming it hasn't been played with. If it sounds rubbish, well, we'll have to come back to it. Testing 1 2, testing 1 2 3 4 5. It sounds really nice and crisp, that. So I'm going to just check it on the deviation meter behind me on the quartz lock test set. And just see whether we've got the right deviation. Whoa, that is low. So they want you to use VR402, if I remember rightly, as deviation. They do. That's spot on. I'll go back to the other test set because sometimes it's working and sometimes it isn't. It's just going to be electrolytic capacitors like everything else, but I say we can't take it off here. Oh, it'd be quite a few weeks being worked on, which would mean no repairs will get done because it's the only test set we've got up and running at the moment, because we're in the middle of this building work and with the organ job, which is priority here. 1 2 1 2 wallow 1 2 wallow 1 2. So it's reading something rubbish because it's not working right. I will just show you. So we know it's doing 2.2 on the other one. Wallow, it's reading 1 on here. Put it on the 0.5, which 1 2 1. It's pegging that, you see, but it's not working on the 5. 1 2 wallow. It's going to be capacitors. Good. Well, there we are. We've done it, and the only thing left is why doesn't the extension speaker socket work? So I'm going to pause the video, unless it suddenly does work now. No, we've got absolutely nothing out of the extension speaker socket. Right, well, we've kind of got it to work. I wouldn't say we've fixed it. I've put an earth link in underneath, which wasn't there before. We have just had to take this power connector out to get to the socket underneath, and I'll just put that back, hopefully, and we've managed to find our way through it. Mr. Chippy's had this extension speaker socket in bits because, as you know, they well, they can go slack, and I took one off an Amstrad here, but unfortunately, although it's exactly the right type, they've cropped the pins as part of the printed circuit board cropping process, and it makes them about 0.5 millimeter too short. They'll go in fine, but they just aren't solderable other than one of them, so it's a shame. So Mr. Chippy took it all apart, which he can do, and he's cleaned it up, retensioned it, and we'll put the lids on. Hope this speaker works after all this. So I think the whole crux of the matter was to research this, find out what it was also available as, and then find a circuit diagram for that version, even though it's not quite right. It's right enough for us to get this working. I wouldn't have known otherwise. It got the wrong audio IC, and that's something I had to check. So I don't need to put it on back on the test set. We do know the set is spot on, and so all we have to do is plug the mic in, plug the power in. Hope I never see one again, though I think I've got one. But the receive sensitivity on this is absolutely unbelievable. Anyway, we'll flick round. Blank carrier from somewhere. One down, Roger. Well, we'll do an on-the-air test to see what happens later on. I'll leave it on 19. It's very sensitive receiver, but we can hear absolutely nothing. Perhaps they're all in bed still. Thanks for watching the Kernow Beta 5100 from around about 1997.